Okay, number 10 says, identify the quadrant where the following angles terminate. And the hint is to draw a picture or sketch a picture. So, for each of these problems, I'll just draw a quick sketch of where the angle might be, and we'll just talk about it. So, let's start with 156 degrees. This one's pretty simple. This would land you, if you know, we start our angles of rotation here on the right. And if you rotate all the way to a half circle, that would be 180. So 156 would put you maybe somewhere like here. So that would be quadrant 2. So 156 degrees goes in quadrant 2. Let's talk about 480 degrees. Okay, 480 degrees, well, if you go all the way around the circle of rotation, that's 360. So it's greater than 360, so to figure out how much angle is left over, you just subtract 360, and that means there's 120 degrees left to rotate. So if you rotate another 120 degrees, that would put you maybe somewhere around here. So that's our total angle of 480 degrees of rotation, and that would be also in quadrant 2. So 480 degrees goes in quadrant 2. All right. Let's look at 5 pi over 4. Now, 5 pi over 4 is on the unit circle. But if you did convert this to degrees, this is actually 225 degrees, which would put us right around here. So 225 degrees would be in quadrant 3. So negative angles means you rotate clockwise from 0. So negative 60 actually just means you rotate 60 in this direction. So negative 60 would actually take you 6 degrees this far, right? Because if you travel 90 degrees, you've traveled the whole quadrant. So negative 60 would keep you in quadrant 4. And then negative 2 pi over 3 is actually negative 120. So if we just kept going to 120, you'd be around here, right? 120 degrees clockwise would just bring you further past quadrant 4. Going backwards, now you're in quadrant 3. That would be 120 degrees because you're past 90. But again, you're traveling clockwise. So that would be quadrant 3. So negative 2 pi over 3. And lastly, if you want to figure out what's going with 13 pi over 6, 13 pi over 6, this one's a little tricky because on the unit circle, it doesn't come all the way to 13 pi over 6. On the unit circle, if you take a look, this angle of rotation is called 11 pi over 6. Now, when you're at 11 pi over 6, you're almost at a full rotation because that's 2 pi. Well, 0 in radians is equivalent to 2 pi, so this is 2 pi. But the reason why it's 2 pi, if you count by sixths, it's actually 12 pi over 6. So if you keep rotating, 13 pi over 6 would be here. So it's all the way past a full rotation of the circle, so it's past 2 pi, and it's 1/6 more. So that would be 13 pi over 6 is in quadrant 1. All right, number 11. Match the trigonometric expressions that have the same value. So in the dropdown, you're given 5 options, and you're supposed to match the options on the left to those options. All right, so let's go ahead and start with the first one. Sine of 60 degrees. So at sine of 60 degrees, you're here. I'll highlight it. You're here. Now, if you look at the sine, remember sine is your y-coordinate. It's square root of 3 over 2. Well, to match this up to one of the answer choices, let me highlight 2 pi over 3. And here's why. At 2 pi over 3, you have the same y-coordinate, square root of 3 over 2. So since those both have the same y-coordinate, they are the same sine value. So that's 2 pi over 3, right? 2 pi over 3. So that would be the same. This would be sine of 2 pi over 3. So that one's done. Okay. Next one we'll talk about is sine of negative 30. So remember that negative rotation means you're actually rotating clockwise. So to talk about sine of negative 30 degrees, you would just rotate on your unit circle I'll zoom in here. Here's our unit circle. So 30 degrees would be rotating this much, right? That's 30 degrees. But if you rotate clockwise, that's called negative 30 degrees. So that would be this direction. So negative 30 degrees is actually equivalent to this angle right here. So 330. So zooming out, we can say that sine of 330 is the same as sine of negative 330. So sine negative 30 degrees. All right, another pretty simple one is, let's talk about sine of pi over 4. Sine of pi over 4, if you look at the unit circle, it's getting kind of crowded. Let me erase some of this. If you look at sine of pi over 4, we're talking about this angle right here. Now, pi over 4, you can see here, is equivalent to 45 degrees. So they have the same sign then. So sine of 45 is equivalent to sine of pi over 4. So that one's pretty simple. Sine of pi over 4 is sine of 45. And lastly, let's see who we can match up with sine of 4 pi over 3. Well, we just go to our unit circle. 4 pi over 3 is down here. Sine of 4 pi over 3 is right here. And that should match up to this angle here, 240. So sine of 240 isn't there, but we can kind of do what we did before. If we look across the y-axis, there's another sine value, and the reason why that one's interesting is they have the same y coordinate, right? That's sine, and that's sine. They have the same sine value, negative square root of 3 over 2. So sine of 300 would also be the same angle. Or sorry, same value. Sine of 4 pi over 3 is equivalent to sine of 300. So sine of 300. Okay, number 12. Given the point negative 12 comma 5 is on the circle with center 0, 0, find the ratio for sine theta. All right, so this is one of those situations where we're going to draw a circle, something like that, and we have a point at negative 12 comma 5, which just means, it's a sketch, negative 12, 5, so we go left 12 and up 5, so something like this. And we have our little right triangle. So we know that this is negative 12, 5. And remember what that means. That means my x-coordinate, the cosine, right, is negative 12. And my height, the sine value, is 5. Now, as I just referred to them as cosine and sine, that's when we're talking about the unit circle. Here, the cosine and sine values are a little different because we have a different hypotenuse. So that's kind of the main issue with this problem. In order to talk about the hypotenuse, we'll call it C, we have to use the Pythagorean theorem. So the legs are 5 and 12. And that's going to equal C. So this would be 25 plus 144 equals C squared. This is 169 equals C squared. If you square root both sides of the equation, you get a C value, or the hypotenuse is 13. So now that I know my hypotenuse is 13, right, you are 13, then to find the ratio for sine, we just need to figure out that sine of our angle, right? Our angle of rotation, didn't draw that in there, our theta. So sine of the angle of rotation, or sine theta, is equal to opposite over hypotenuse. And now that we've solved for the hypotenuse, from this angle, our opposite would be the 5. And the hypotenuse would be our 13. So I'll leave it up to you to type in 5 divided by 13, and you'll get a decimal that you can just place as an answer, rounded to 3 decimal places. So I'll let you do that on Desmos. All right, a similar question, number 13. So I'm going to draw my right triangle, and the point is 6 comma negative 5. Let me draw my circle, something like this. 6 comma negative 5 means we go right 6 down 5, so maybe something like this. Right, we got our little theta. All right, so now the height is negative 5, the x is 6, right? 6 comma negative 5. And then we need to find our c value, right? Our hypotenuse. So I'll do it over here. 6 squared plus 5 squared equals c squared. 36 plus 25 equals c squared. 61 equals c squared. Take the square root of both sides, and we get the square root of 61 is c, which is not a nice number, but it works. So this is square root of 61. And if we want to find sine theta, which is the same ratio as before, sine of theta will equal opposite over hypotenuse, which for my theta, that would be my negative 5 over the hypotenuse, which is the square root of 61. And that's not a very fun expression, but you could just type that into Desmos and place the decimal value as your answer. All right, number 14 and 15 makes you recall some information about coordinates. Now, if you remember, we had a handout where we talked about the different quadrants and what sine and cosine do respectively in those quadrants, but it all really comes down to if you know what the coordinates do in these quadrants. So if you remember, in general, we can say what the values of points are in different quadrants. So in quadrant 1, it's always a positive and a positive. So this is quadrant 1. In quadrant 2, it's always a negative positive, right? Because you're going left and up. In quadrant 3, it's always negative negative because you're going left and down. And in quadrant 4, it's positive negative because you're going right and down. In order to talk about cosine, we have to remember that cosine is always the x-coordinate. Wherever the x-coordinate is negative, right? Because this value is negative. It doesn't really matter that we're talking about specifically about negative 0.743, but it is a negative value. So that would be quadrants 2 and 3. So 2 and 3. Those are the answers. Now, with my same drawing, I can look at the next question and see how it says that sine equals a negative, right? This is a negative value, and this is sine. So just remember that sine is the y-coordinate. So where are my y-coordinates negative? That would be quadrant 3 and 4. Okay, got my quadrant set up again. Okay, now tangent. Tangent, if you recall, is equivalent to the expression, which I give it to you here on the problem. Tangent is a ratio of sine and cosine. It's sine coordinate, your y coordinate divided by your x coordinate. So if you were to divide your two coordinates and you still get a negative, in which quadrants can you divide by your divide your y coordinate divided by your x coordinate and get a negative? Well, that just means you're dividing by different signs. In quadrant 2, you have a positive divided by a negative, which is negative. And in quadrant 4, the y coordinate, you have a negative divided by a positive, which is still negative. So in those quadrants, you get a negative. Now, the next follow-up question says that cosine is a positive value. That just means where's your x coordinate positive, which would be quadrants 1 and 4. Because that's where the x coordinate is positive. We know that sine is equal to negative 4/5. So we have a negative sign. And we know that cosine is positive, right? This just means positive. When something is greater than 0, it just means positive. So I know that sine is a negative value. So that means my triangle can either be here or here, right? Those are my options. And it's negative 4/5, which remember, this means you're opposite over hypotenuse. So it's either negative 4 and 5 like this, or negative 4 and 5. Remember, they're telling us that cosine has to be positive. So if cosine is positive, that means your x has to be positive. This would be a negative distance, right? If you got the value here, this would be a negative x value. But over here, it'd be a positive x value. So what that means is we have to throw away this triangle, and the triangle on the right would be my correct triangle. And I'll leave it to you to confirm this, but if we called that x squared plus 4 squared has to equal 5 squared because of the Pythagorean theorem. I'll leave it for you, but x does equal 3 because this is what we know as a 3, 4, 5 triangle. And if I wanted to write tangent, just remember that tangent theta is your opposite over your adjacent. So my opposite would be negative 4, and my adjacent would be 3. So this would be negative 4 over 3. And similarly, we have a question here. This one's kind of nice because it explicitly gives us the quadrant. So if you're between 90 and 180, you actually are for sure in quadrant 2. So that's nice. They give us the quadrant. There's my quadrant for sure. Quadrant 2. And cosine is -7, square root of 7 over 4. Remember, that's adjacent over hypotenuse. So that means this is my adjacent, negative square root of 7. And my hypotenuse is 4. And we need to find sine. So to find sine, we do need to know what this opposite side is. So I'm going to use the Pythagorean theorem. So square root of 7 squared plus b squared equals c squared, which is my 4 squared. So now we get 7 plus b squared equals 16. Subtract 7 from both sides. B squared equals 9. And the square root of both sides of this, b equals 3. And it is positive because it's going up on the y-axis. Sine of theta is our opposite over hypotenuse. So my opposite from theta would be 3. And my hypotenuse is 4. So my ratio should be 3 over 4.